Several months back, I wanted to build a single-ended EL84 or SBQ5 Hi-Fi amplifier. I was looking for a good schematic online, and I found a modification of the Magnavox 8604 done by David Gillespie, and it is a simple circuit, but I slightly modified it and added the using just one double triode per channel. So I used both halves for one channel. One half of the 12AX7 is used to control a simple EQ. I will show you the schematic, the full schematic, in the next video, where we'll be concentrating on the build itself. But currently I designed the PCBs and populated them. And now it's time to actually calculate and wind the transformers for the stereo build of this small hi-fi amplifier. I was also thinking to add a headphone option, headphone tap next to the speaker tap on the output transformer, and of course I will be winding the power transformer as well. At the same time, I've finished the brand new online version of my calculator, transformer calculator, which includes the standard, so power transformers, single-ended output transformers, and push-pull output transformers. It has many improvements. This version is called Transformer Calculator Pro because I added some of the features which I always wanted to add, but they were just too time-consuming. And finally, I added all the features I wanted to have for power and output transformers. So if you check the link below, this is the new Calculator Pro. You can purchase it on my website, and once you log in, you will have the three options. So first we will calculate the power transformer. You can see the goal, one of the goals was to have no fancy interface, just to have simplistic interface where you can see everything. If you use the usual number of secondaries, you can view everything in a single page and have a good overview of the page. I've also added the save and load buttons, so now you can save your transformer calculation to your PC, and of course none of the data is saved on my server or anywhere else, so you save directly to your PC and you load the files directly from your PC. So here we can start the calculations. You can see here you have the basic transformer data. You select your mains frequency and the flux density. If you don't know your flux density, you can leave it at this value without any problems. In this case, I know I will be using slightly better core, so I can bump this up to 12K. And here we have the wizard section. So once you type your primary voltage, your mains voltage, you can go here and add your secondaries. So in this case we have the first secondary, and the first secondary we will use, for the first secondary we will use the 300 volts. This is a no load voltage, and our current is 0.05. Also, so we will add another secondary, which will be the same. So it's a second tap of the secondary. And now the nice thing about this is that you can name them. So you can name them high voltage B plus, 300 volts, AC, and you can type B plus 300 volts AC 2, and you can add another one, so we can add filament 6.3 volts, and then we can use a slightly higher voltage, so 6.7 volts at 1.5 amps, and I will have a separate, so we can call this left, and we can call this filament 6.3 voltage, right? So we can separate it for two channels. It's just easier to wind with a thinner wire and just wind a single, like to wind two separate windings, but with a single wire gauge is easier, because it's a low turns winding, as we will see shortly. So 6.7 and the same 1.5. I will also add another one, which will also be, this will be rectifier filament. In this case, it's also 6.3 volts, but we will use a slightly lower. And of course, we can put one amp is enough for the heater of the rectifier tube, but I will probably just wind it later. We will add a custom gauge. I will wind it with the same thickness, so I don't have to change the spool. I can just wind it as I go. So this is the list of all our wishes for the secondary and primary. And now, since we don't have anything for the core, we can focus on the wizard calculation, which is a great helper if you don't have experience, and even if you have experience, it's really good and really fast. It really speeds up the process. So in this case, we can choose. You don't have to choose the exact value you will be using in the wizard, but it's good to just click on the closest value to what you will use, because then it will automatically populate the window height and window width and the correct core. So with just one click, I can select it here, and it automatically populated everything, and you can see that it already calculated the number of turns according to the to that core properties. So it's really useful. And let's say you want to use a different one, so like I have a 2.5 and 3.5. You will get these results, and then of course you can keep the original. It doesn't matter. You can modify it or leave it as it is. It's important to check the stack fill always. So once we add the custom gauges, we will see the custom stack fill here, and whether we can fit the wire to the bobbin using our custom gauges. So now we have everything calculated for us, and we can put the custom gauges we will use. So let's say we will use 0.15 as recommended. Also, you can type here the AWG wire, and it will automatically convert it to millimeters and the other way around. So also nice feature if you buy your wire as an AWG or in millimeters. You can choose whatever it's good for you. Here we have 0.8. I will just wind it with 1. Most probably, or 0.9. Let's see if it will fit. And here we have the primary, which is 0.35, and we see that we fill the bobbin to the to the teeth. It's 99.65. So of course these filament windings, they have a lower number of turns, and it's quite possible that since that they will fit, for example, 2 of them will fit in one row, so this calculation, so they will fit. But I must say that this will be a really tight fit, so this might not work out. But I would, up to 90% you are definitely safe. Above 90 it's still doable, but it has to be really tight fit. And so in this case I would probably consider using a slightly the next core, so the 84 core, which is 2.8 by 3.5 is quite good, or we can use this one, 2.8 by 4. I think I will go with this one. This is a nice safe limit. This would be easy to wind. And now when we have everything as we like, we have our custom gauges. You see, it took us only a few minutes, even with me explaining all the features. You have your full calculation for all the windings. And now you can save it. You can press save and you can call it EL84 SE Power Transformer Stereo. And you can save it. And it's saved. So now if you would load an empty page, you can load this from your PC, and it will load everything exactly as you left it. So you have a perfect way to save your and organize your transformers, and it keeps everything, the interface, nice and light. And so that's it for the power transformer. Quite simple and fast, and very useful with the wizard calculation, where you can now click and select. You can also, of course, remove the windings, add, and it's quite handy. Okay, let's move on to the single-ended output transformer. So our output transformer, which will have one speaker winding, and it will have also headphone winding. So I will show you all the new features. This has even more features than the power transformer, and I also went with the same style so that you can see everything clearly in one page and there are no distractions. So in this case, we have our secondary, we have our power, which in this case will be 3 watts, and that's the lowest frequency we are expecting. We will put 25. Of course we will get 20 hertz, but we'll just put 25 here for now. And the plate load in the datasheet is 5200 or 5K, whichever you like. It's not gonna make a huge difference. And we know that we have 50 milliamps for the plate current for a single EL84 or 6BQ5. Okay, on the secondary side, we have the speaker. Of course, you can leave 8 ohms. I like to use 6.55, and you can add now this plus, the green plus at the top of within the secondary winding, adds a tap. So now you can add taps to secondary. So you can have a tapped secondary. If you would wind, for example, let's say I want to have 4, 8, and 16 ohm speakers. So I can put 4 ohms here, and then put here speaker. This is a 4 ohm tap. We add another tap, which is going to be speaker 8 ohms. And then I can add another one, which is going to be 16, and I can call it speaker 16 ohm tap. So whatever you like to call it, it doesn't really matter. So it will, what this is doing, it's calculating all three as a continuous winding, but the current is calculated for each impedance, of course the number of turns, and then the number of turns will adjust. So if I of course we have the wizard, which works the same as for power transformer. It gave us already the recommended sizes. So we can try one of these, and for example, we could use, let's say, this one, and we get so we would get quite a large number of turns for this one, and we have 161 turns for the 4 ohm tap, and then we don't have another whole new tap. We are just whole new winding. We are just adding windings to the tap. So we would wind 161 turns of 0.6 millimeter wire, and then we would continue that. So connect the end of that tap to the beginning of the 8 ohm tap, and we would continue with the 0.5 wire. Of course, we could use the same wire, but we don't have to. We can use thinner gauge wire, so we can fit more, and we can add another 67 turns, and then we can finally use 0.4 wire for the 16 ohm tap and add another 94 turns for the 16 ohm tap. So in this way, we don't wind from scratch each of the windings for their number of turns. We use tapped windings to achieve it, and this calculates it automatically without you having to think about it. And you can add, of course, a new another winding, which is the blue button down here, the blue plus. It will add a completely separate secondary, which we can call headphone, and we can use 30 ohms. So here we can put 30 ohms as a separate winding, and of course we could extend these the speaker winding and just add another tap for 30 ohms. So in that case, you see here it's 441 turns that we have to wind. But if we would add it here as a headphone tap and put 32 or 30 ohms, instead of winding another 441 turns with 0.37 wire, we can wind only 119 turns of 0.37 wire. Of course, this is not linear. This goes with a square for impedances, but still you save a lot of space when you need to have multiple windings in a transformer. So this is another nice feature. The save and load works exactly the same. It will save all the data, all the taps, all the secondaries, everything exactly as you left it. And also this interleave pattern works only for a single winding. So if you have a single winding, for more complex interleaves, you would still need to do it manually, because there are so many variants. But I'm thinking of making just another module where you can import your transformer, and then you can divide and put the order which you like for each winding. So make your interleave pattern yourself, which I think I will add to this page eventually. But for now, the standard windings with one speaker or one secondary. I mean, you can put all of the secondaries also and in between, but yeah, it calculates it only for the first one. Okay, and so now you can save, load. You can also add the ultralinear if you would be doing that. So it would tell you the plate turns and the screen turns. And you can also, if you switch to guitar amp, it would give you lighter transformer, so to be similar to what Fender does and other guitar manufacturers. So it would give lower flux density, a lower number of turns. Of course, I will be using a different, slightly higher value here, and I will be using 25 by 20. Where is it? Yes, 25 by 25. And yeah, so this would be the calculation. Also, if you're using, I will be using slightly better core, you can also increase up to 6,000 this. Of course, depending on your core, if you have some super high efficiency core, you can use even higher, but I would not recommend going even if you have better core, because I think it's better to keep it lower. You would get a better sound, in my opinion. So we are here around 2,942, so that seems to be a reasonable number. And of course, I will not be winding all these tabs, so I can just remove the tabs I don't need. I can change this to 6.55. I can remove this one as well, and I will keep the headphone one here. So yeah, this is I think I will be going with my standard either the 3 primary to secondary. This gives a really good high end. It is probably overkill for this amplifier, but you could just do the one interleave to put half of the primary. This would give you very nice results. Maybe I will go that route, or I will wind it like this. We will see in the next video what I decided. Still not sure, but yeah. So you can see it's very easy to calculate. It's very easy to change the calculations and try different things. You can then save it and save different versions of it. So for example, I can save it as SCOT plus headphone and save it. And then of course you can load it the same as with Power Transformer. So if you like this video, stay tuned for the next part where we will be winding these transformers, and in part 3 probably we will assemble the whole amplifier and test the transformers and have a listen of the amplifier to the amplifier. And of course, if you would like to calculate your own transformers, you can check and purchase these the access to new online transformer, and you have some other options there. So check out my website. Of course, if you already are already bought all the previous calculators, you can get this latest one for a discounted price, so for $10 at this moment. So just please contact me, and I will send you the link for that. And also, if you are a long-term patron on my Patreon page, also please reach out, and but you will get it for free. Okay, thank you for watching, and go and wind something.